Going to start
I'll
recording.
cover.
I think I gave an assignment on. I gave an assignment. Sorry, please just hold on. I gave an assignment last week. Let me see the assignment. Yeah. So can you see my screen? Confirm if you can see my screen.
Yes.
Okay. So I was talking about. So we discussed loops, right? And we discussed statements. So one of the loops we discussed were for loop as well as if statement last week. I don't know if you were in the session last week, and with that, I gave an assignment to find prime numbers. Basically, that's what I did. Um, uh, it, it, I'm hoping that whatever knowledge we have done so far, we'll be able to use to apply this to do that. Just give me a moment. I need to pick this call. Tired. How are you? Welcome to this particular good
Good evening, sir. I'm fine.
evening. How's everything?
Thank you.
Um,
Fine, thank God.
this you are just joining for the first time, I assume. I don't exactly know why you.
Yes, I didn't know this particular class had started.
I were you amongst the that were interested in the Python session.
Yes, yes, I
Oh,
was.
okay, okay. And so just try and keep up, right? I don't think I would want to go back because I recorded every other thing.
Okay.
I would I would resend to the different sessions we had. So it will just
Oh,
help just most likely listen. Um yeah.
oh,
So
thank you
um
so much.
you're welcome. Um we are going to solve the prime number problem. So basically we are saying that write a Python script to ask a user to enter a number n and then print all the prime number between 1 and n. And so I give some guides. So prompt the user to input a positive integer, check all the number between 1 and that imputed number. Um, the last thing is print the prime numbers basically. And so um, huh, So, what is a prime number? A prime number is something that is divisible by 1 and itself, right? Is that not? Something that can divide
Yes,
by 1 and itself. So, something like 1 is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number. Is that not? Um, if, if a prime number divides by 1, is going to give that prime number. If it divides by itself, it will give 1. Is that not? So it's just logic. So let me go back to. So I'm going to create my prime number assignment. So it's a Python script. So you are going to name it .py extension. And so we said prime number, right? Prime number. We said is something that is divisible by divisible by 1 and itself. So what does that mean? If prime number divided by 1, sorry, hold on. If prime number divided by 1 would give you prime number. That's itself. If prime number divided by itself, divide by prime number, that's itself, then it's going to give you 1. So this is what the prime number is, right? So how then do we solve this problem? Now we are going to say, so we said the user should take an input, like, so a user can actually enter any number, and so we are going to check between 1 and that number all the prime numbers. So for us to be able to take an input, we are going to use this particular method, input, right? And so we want to assign it to a variable. It can be anything. I'm going to use Hidayat's name here, just to, maybe I should use who, okay, I see Zainab, so I'm going to use Zainab. And in the previous video we mentioned what a variable is, and so we want it to take an integer. How do we prompt it? First of all, if you take an if you are assigning an input, you have to enter like a guide. So say enter only whole numbers here, and maybe put a hyphen. Is this a hyphen? What's the name of this? Forgotten the name of this. I think I need to improve on my English. Now, what does this do? If I say print the variable, then I save, and I would say pi, I would say prime underscore no dot pi. You can see it's saying enter whole number. This is exactly what I entered here in my input, and I can just say, the unfortunate thing is that if I enter a text, for instance, I'll say Hidayat, it will just print out Hidayat. Now, how do I prompt it to take only whole numbers? I'm going to enclose this particular input with an integer. So integer are whole numbers, and in Python they are referred to whole numbers. So I've now prompted it that it should only take integer. Now what happens if I run this particular program again and I enter Hidayat? It's going to prompt an error, and it's saying that the value error here is saying invalid literal for int with base 10 Hidayat or something like that. So anyways, I could name this any kind of variable and it works fine. I'll print this. Now what's the next thing, right? We are now going to say, we'll use our loop. We want to loop through all the numbers between 1 and this number. How do we do that? I'll say for prime number, or just a prime in A, and not in A but range. So the range takes about 3 attributes: the start, stop, and the step. So the start, which is I want to start from 1. Where do I want to stop? I want to stop in A. Then if the default step is 1, so it's like 1 2 3 4 to wherever A is. If you say A is 10, it will be 1 2 3 4 5 6 7 8 9. Unfortunately for ranges, it's going to minus the last number. So let me show you what I mean. I'll just say print, I'm just going to say print A and save this. Now once I run the program again and say enter whole number, if I say 10, it's going to print, oh sorry, it's not supposed to print A, but it's supposed to print prime. Sorry about that. I'll run it again. I'll enter a whole number, let's say 10, and so let me just expand this so you guys can see. So you can see it's going to take 1, that is this 1 here, up to 9. Unfortunately, I entered the value of 10, so a range usually would take out the last number for some weird reason. So I'll just say +1, And so by the time I save and run this program again, I enter 10, it's going to print everything plus including the last number, which is 10. So if I say step of 2, for instance, so it's going to count from 1, then it will take the next step, that's plus 2, will give me 3, and so on. I would say, let's say 13. So it will give me 1, so 1 plus 2 will be 3, 3 plus 2 will be 5, like, and so on, up until 13. And so this is what the step do, but by default the step is 1, so I don't really need to enter a step. So what's the next thing? We said we want to start doing a check. If prime number is if prime number divided by 1 equal prime number, so we'll then enter our if statement. So we'll say if prime divided by 1 is prime, or yeah, so sorry, is equal to prime, which is double equal to. So that's the first step. And if it's divided by 1, I'll just say print prime. Print prime. Right. I'm going to save it. I would run my program again to see that everything works fine. I'll enter maybe 8. So it's going to print 1 to 8. So basically I'm saying is, does 1 divided by 1 equal to 1? If it does 2 divided by 1 equal to 2? Does 3, so on and so forth? That's the first test. If it does that, it means that we are fine. So what the next test is, if this first test is successful, do another test. I'm now going to do another if statement and say if prime divide by the prime number. Okay, so I think this is a problem. Okay, apologies. I thought about a problem, but let me try. This is wrong, but I thought about a problem. This is not
Yeah,
the
sorry, sir. Well done, sir.
who's talking.
It's Taiwo, sir.
Okay.
Yeah, I think there's a method called this remainder. So can't we use that remainder in this our logic?
We can. I'm just testing different logic. We can.
Oh, okay, sir.
We can. Wait. I'm trying to get somewhere. I'm trying to get somewhere. So if I then run this particular program and I put 7, it's still going to print 1 to 7. So I've basically not done anything. Which is the mistake I think I made. Now, so a prime number is neither divisible by 2 or divisible by 3. A prime number cannot be divisible by 2, and it cannot be divisible by 3. So for instance, 6 is not a prime number because it's both divisible by 2 and 3. 9 is not a prime number because it's both divisible by 1. So 6 is, you can divide it by 1, 2, and 3. 4 is by 2 and 3. 9 is by 1 and 3. No, so 4 is by 1 and 2. 5 is a prime number because you can only divide it by 1 and itself. Does that make sense? Hello? Can you guys hear me?
Yes, sir. We can hear you, sir.
So if I want to use the remainder, that might be a problem.
Sir, what if you use from this?
Hello, Mr. Are you saying something?
Hello, sir.
Yeah, I can hear you.
So from that second statement, from inside the loop, what if you say if the prime number is divided by 2 and is equal to 0, then that is not a prime number anymore. Then we can now print our statement from that place. Can we do that, sir? Is it possible?
Sorry?
Can you hear me now?
I can hear you loud and clear.
Now, what I'm trying to say is that from the if statement, if you say if that prime number is divided by 2 and is now equal to 0, that is, it is out of the what we are trying to achieve, because every prime number must not, after divided by 2, must not equal to 0. So automatically that is not a prime number. That is, if that prime number is divided by 2 and is not equal to 0,
That's the remainder of it is equal to zero, right?
0, yes.
Uh-huh.
If it's not equal to 0, automatically that is not the prime number. For instance, now, if that prime number is 2 and we divided 2 by 2, automatically we have 1.
Mm-hmm.
Are you getting me, sir?
Yes, I can. I'm trying to understand.
Okay.
So you are saying
So,
divisible by 2 will give me 1, right?
yes. So anytime we now divide that prime number with 2, if it's giving us 1 or is not equal to 0, that is, that should not be a prime number anymore. Then we can now print our statement from there.
Okay. Let me see. So how do we take care of 3?
3. Then we can now say 3 divided by 2. Automatically if you say 3 divided by 2, we can't get prime number again.
Okay.
So anytime we divide any number by 2, we always get an even number. So automatically, once you get an even number, meaning that that is automatically a prime number, because a prime number should not be equal to, or it can only divide as far as you can. It doesn't have any value less than 0, or it doesn't have value between 0 and that particular prime number. Maybe I should try to type it so that maybe you can get it from that place.
Yes. That
All right, sir. You can continue, sir.
no problem. Type it so that I would see what you are saying. Oh, this is interesting. Give me a moment. I'm trying to think. The math of this thing is just crazy. I think I'm not supposed to add I'm not supposed to actually print 1 in this again. I think I'm supposed to print from 2. Sorry, that reminds me. Okay, so that reminds me. So let me try out something. Um Let me try out something. Let me say if hmm, if a modulus prime is equal to 0. Think this should work. Um, let's see. Hmm, It is not equal to 0. I think is what I'm supposed to use. Not equal to 0. Then um hmm, I think I'm supposed to also create a list. I would say sorry, b dot append
Yeah,
prime.
sorry, sir. I think it should be equal to, sir. If that module is divided by prime number, it should be equal to, not yeah, exactly.
Let's see. Then I would then say print b. Let's see. Um, the prime number logic is crazy. I'll put 10 and let's see all the prime numbers. Okay, it's skipped out on. So there is no 3, there is no 7, and 10. It's not. It's wrong. Hold on. So it's not supposed to print out 10. I think is not equal to. Let's try that and see. Um, Let me enter 10. It's not even supposed to print out 10. So okay, it's skipped out on. Oh, interesting stuff. This is weird. Hold on. Save this and run it. I hate I hate cracking my head like this. um, Where's the other? Sorry. Wow. So something is wrong. I'm supposed to test it by like a divided by this. But okay, hold on. Okay. I just thought about something. ah, ah, sorry, please just give me a moment. I thought about something and let's see. Just hold on. I think I'm going to do another loop for test in prime. I think, hold on. Range 2 to prime, and this is a plus 1. Right? Trying to test out something. Um, if test modulus uh test modul sorry, if prime modulus test is equal to 0, then break break, then I would say b dot append b dot append prime. Let's see what's going to happen. Cheers now. Guys, I'm going to give up for today. So 2, 3, 4, 2, 3 is correct. 4 is not supposed to be there. Okay, sorry, just give me a moment. I would say this underscore prime is equal to true for this. Then I'll say is underscore prime equal to false. Let's see what's going to happen. Then I'll then say for this break, I would say if is prime, then I would say b dot append prime. Let's see what's going to happen. Just give me a moment. And oh yeah, let me test it for something big. Let's say 20. I have 2, 3, 5, 7, 11, 13, 17, 19. 16 is not a prime number, 18 is not a prime number because it's divisible by 1, 2, 3, 9, right? It's going to 20 is not a prime number because it is going to be divisible by 1, 2, 4, 5, 10, and 20. But this is it. Oh, okay. Can you guys hear me? I was just trying to do a test to see. Um, confirm if you can hear me. Hello.
Yes, sir. I'm with you, sir.
I guess everybody became bored. So, why I why I said is I give a variable equal to true. This is a variable. This is any variable, and it's because 2 is a prime number, right? So automatically, if we are looping 2, we are just going to get 2. So 2 basically is a prime number, which is why I just set a variable called true. Now, I now did a loop of so I'm going to go through between um whatever this prime number is, that's between 2 and whatever a is. So it will be 2, 3, 4, and I'm going to do a test. Is 2 divided by 2 is it equal to 0? Yes, it's going to we've already added 2 here. If it is equal to 0, so something like 4, 6, what else? We have 4, 6,
8,
8,
10,
10.
12.
Understand? So it is going to, if it is equal to 0, it's going to break. And once it breaks, I will now do a test. If this prime number, basically if this particular variable is equal to true, just append it. So anytime that number between 2 and whatever number, so 2, 3, 4, 5, 6, 7, 8, 9, 10, anytime I divide it by 2, it gives me 0, it's going to skip that particular one and move to the next. So the same thing with 3 as well. So it does this particular test over and over again. This is a very, very long process until, so anytime it's divisible by 2 or 3, it will just break and move forward. It will go to the next number, test it. If it's divisible by 2 or 3, it moves forward, test it again. But I think there's a simpler way I can actually do this. Just give me a moment. Um, uh, just hold on. There's a simpler way I can do this. I'm just trying to wrap my head around it. Ah, okay, so there's a simpler way I can actually do this, right? Let me see. I'm going to keep this. I am going to set divisor one like a divisor, one as 2. Then I'm going to replicate this. So I really want to, these are my tests for prime numbers. So I'm going to look between prime and a range of 2, and I'm not going to start from 1, and what a is plus 1. I would say, in order for my, um I will do it like a logical test. I can say if prime is 2 or prime is 3. So automatic, prime is equal to 3. I will say b dot append this prime number if it's equal to 2 or 3, right? I will then say else. I will say if this prime number modulus 2 is not equal to 0, I think this was what I was trying to do, and if this same prime number modulus 3 is not equal to 0, right, I will then say b dot append prime number. Then I think this will be it. I'll save it and let's try it again. I think this is like a simpler method. Oh, what did I do? Oh, sorry, I'm not supposed to use this if. I don't know why I did this. If is supposed to come only once. So let's try 10 again. So I have this. I'll try 20. Oh, this is interesting. Let me try 40. So I'm going to get 21 is not a prime number because it's divisible by 3, 7, 1, and 21. 22 is not a prime number because it's divisible by 11, 2, itself, and 1. 23 is a prime number because it's only divisible by 1 and itself. Oh, 25 is not supposed to be in this equation. I think I'm also supposed to add 5. Yep, I'm supposed to add 5. Let's see, or prime equal 5. um, I'll say and prime because 5 is not supposed to be, anything that is divisible by 5 is not supposed to be there. It's not equal to 0. Let's do that. And I'll try 40. So we have 24, 25 is not supposed to be there, 26 is not supposed to be there because 26 is divisible by 2, right? It's divisible by 13. 27 is not supposed to be there because it's divisible by 3, and it's also divisible by 27 is divisible by 9, right? 3, 9, 1, and 27. 31, 32 is not supposed to be there, 33 is not supposed to be there, 34. Is 35 supposed to be there? 35 is what? 7 times 5, right?
Yes.
So it's not supposed to be there because it's not the prime number. 36 is not supposed to be there, 37 is there, 38 is not supposed to be there, 39. Okay, this looks okay. So basically what I just did was, actually I'm supposed to say divisor. I'm not supposed to use, so I'm supposed to say divisor here. I'm really not supposed, but this is fine. This doesn't really matter. This is a hard code. So what I just did is I did the first loop and I say look into whatever is between 2 and this particular input. Constant that are there should be 2, 3, and 5. This is a hard code, just add it. You understand? But I think this problem is fine. Um, um, so just add it if it is beyond 5. Otherwise, you can then do this particular number divide by 2. If it's divisible by 2 is not equal to 0, add it. And so I'm going to test for prime number between 1 and 5. Let's see. Okay, I will test it between 1 and 4. Okay, good. Let me test all the prime number between 1 and 3, 1 and 2, and let's see. I just wanted to test it theory, just only 2. We test between 1 and 3 to show me 2 and 3, 1 and or 2 and 6, all the numbers between 1 and 6. Okay, good. I was trying to test something and see. And so automatically 2, 5, 2, 3, and 5 is automatically a prime number if the number is up to 5. Otherwise, if it is beyond 5, do a division for me by 2. If any number that is not equal to 0, add it. If you divide it by 3 is not equal to 0, add it. If you also divide it by 5, if it's not equal to 0, add it. But this is like a hard code. This is not I wouldn't advise this because this particular code will break after a while. The code is going to break after a while. If you run it with longer numbers, you'll find out that some numbers will divide huge numbers would have lots of divisor or something it can divide with. I am curious to see. Let me see 100. Let's see the numbers that will come between so 54 is not there, divide by 2. 55 can divide by 1, 11, 5. Interesting. It doesn't break till 100, at least not up to 100. Okay, but I think the code will break after a while. I'm not sure when, but it's going to break after a while. So I don't think this is like the best method to actually use to get prime numbers. Unfortunately, this session will be coming to an end in 15 minutes. Any questions? Any questions?
No questions so far, sir.
Okay. I wanted to talk about list comprehension. I think it's just the one thing I'm going to add before I leave. So we did for loops. Let me see. I think we did it somewhere around here. Loops, and we use this to solve odd and even number. So I had a list, and I wanted to get all the odd and even numbers. So I had a list of 1, 2, 3 like that. I wanted to get all the odd numbers, print it, and all the even numbers and print it. Now, so we what we just did is what did we do here? Oh, okay. So what we did is we said between 1 and any number you impute, let's get the odd number and let's get the even number. So odd numbers are numbers that when you divide by 2, it doesn't give you 0, right? It doesn't give you the remainder. It gives you remainder. So 2 divided by 3 will give you 1 remainder 1. 4 divided by 2 will give you 2 remainder 0, something like that. If you guys remember long division. So anything that divides by 2 and gives you a remainder is a odd number. So I use so you guys should watch tutorials and see what I used for loops for. But this time around, I'm going to use what they call a list comprehension. So it's list comprehension dot py. Now, I'm going to, so basically what I want to use my list comprehension for is to get list comprehension to get all the odd and even number between 1 and any number I type into my input. It will just give me all the odd numbers in a list and all the even numbers in a list. So basically the same thing as what I did before using the for loop to get odd and even number. So I'm going to put a a variable which is an input. So I'll put it an integer, then I'll put input, then I'll say enter a whole number here. So when I'm done with that, I will then say I'll create a new variable to get all the odd numbers, and I'll put it in a list. The same thing for even number, I'll put it in a list. Now, instead of me to go through all that problem of saying for item in range between 1 and b and so on, get the odd number, append it, even number, append it. What I can just do is what they call a list comprehension. So what the list comprehension will just do is I'll put my for loop and if statement in a list. I'll say item for item in range, and I'll say range between 1 and my input plus 1. I'll now say if item modulus 2, this is for odd numbers, is not equal to 0. And basically for the even number, I would say even for I, the same thing if item modulus 2 is equal to 0. So basically what I've just done is this for loop is inside my list comprehension, and this if statement is also my list, is inside my list comprehension. This else if is not there. So I've actually just used the for loop and if statement in one list. And so by the time I then say I want to print my odd number, and I also want to print my even number. So if I want to make this more interesting, I'll just say I'll put this in I'll say odd numbers are, or I can say I'll use the f string I'll use the f string odd numbers between 1 and I'll then put this my variable. I will now say I'll just say odd number, and I don't need this. And I would do the same thing for even number just to make it more readable. So I'll say even numbers between, basically, so this is not I, is 1. Don't know why I pressed that. And I'll just say even numbers here. Then sorry, I'm just going to save it. I would run this my code, my script, and I'll say .py. It will ask me for a whole number. I would say 20, and you can see I have all the odd numbers between 1 and 20 are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. These are odd numbers between 1 and 20. And the even numbers between 1 and 20 are 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So basically, you can actually use list comprehension to do the work of a for loop if you are returning a list. Again, I really advise you guys should go and check out the previous video. It's going to explain a whole lot about the for loops and the if statement. So a list comprehension, you use it to, if you are returning a list from using a for loop and maybe and or an if statement, you can actually use list comprehension for it. So this basically does, you can see, let us just remove this guy here. Yes, this is not part of the code. So for us to do this for us to do this, to find out the number between 1 and any input I enter, I have to write line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But for list comprehension, I just add 1, 2, 3, 4, 5. So the number of codes I wrote are just 5 lines. For using the for loop, the number of codes I wrote are actually 9 lines. And so the list comprehension would make everything less bulkier in terms of script. I don't know if it is faster, but I think it is less bulkier. But we can test the speed of it and see. Let me play this and let's see. Enter a whole number. I'll enter 20. Oh, cannot edit. Let me see. Oh, I can enter this in an output, but I want to see which is faster. I would just comment on this and just enter a number instead. I'll say b equal to 20. Let's see the speed of it, how it runs. Oh, code is already running. Interesting. So it took us about 40 seconds to run this code. Let me do the same thing for this. I don't know which is faster anyways, but I'll say this is 20. I would run this as well. Okay, so I ran this particular two codes. Okay, no, these two code. The using the for loop took about 0.179 seconds, and this is 0.188. So actually the list comprehension is longer to execute. Let me try it again. It's about 0.127. Let me do this. So the list comprehension is longer. It takes longer time to actually execute, which in the grand scheme of things is usually a problem. If you want to write code, they are like best practice to it. It needs to be neatly written, and it also needs to be extremely fast in executing. Unfortunately, for the list comprehension, it doesn't work that way. It's not really fast, and that's because I think I can understand that I'm using 2 for loops in a list, while this one I'm just using 1 for loop, and I think that's the reason. If I remove one of these for loop, it means I have to do this, save it and run. I think it will be less cumbersome. So 0.17 seconds, even though it's not giving me the same thing. This is 0.1. It's still, the list comprehension obviously is not the best way to write very fast codes based on what I'm seeing. I just wanted to test that theory out to see. So it just makes it makes you write less code but not really fast. And a lot of times fast is key. Effective code, but you have to be fast as well. It's really key. You'll be so shocked if you are writing very fast codes. I think I'm just going to stop here. Hopefully tomorrow we'll discuss about functions and classes. Hopefully. Any questions before we leave? Any questions? Okay, Mr. Tai, we don't have any questions. What of the other participants? Any question? Anywho, without any questions, see you guys tomorrow. Have a wonderful day. I think I'm going to stop recording now. I'll send the recording pretty soon.